Alright, today we're going to start with the year 10 trigonometry. Okay, so we review all the stuff that we did last year. So we did the SOHCAHTOA, we do elevation, depression, bearing, and I'm assuming that you've done all the questions that I asked you to do. Okay, and then we're going to move on to the year 10 stuff. Now, next thing that we're going to be doing is something that we call the sine and cosine rules. So I want you to copy that heading, and then I want you to copy this diagram. Yeah. I don't have any here. Yeah. Okay, so what you can see here, now we're going to be dealing with a non-right angle triangle. So I mean that everything that we learn with the SOHCAHTOA won't apply. Okay? So SOHCAHTOA only applies if you have a right angle triangle, but it doesn't apply when you have a non-right angle triangle. Now, in year 10, at this point, I'm gonna give you the formulas, and later, if we have the time, we're gonna actually prove them. Okay? And in year 11, definitely we're going to prove all formulas. Okay? So in here, I'm just going to state what the formulas are, and then we're going to do some questions, and then that will help you with your assignment. Okay? All right. So we have two formulas. We have the formula for something that we call cosine rule. Okay, so let's say cosine. And then we have the sine rule. Still we're going to be using trigonometry. Still we're going to be calculating, the sides of a triangle. Still we're going to be finding the angle between two sides, which is one of the questions that you have in your assignment. Okay, so you need to pay attention a lot, otherwise you're going to get lost very, very easily. Okay, so this will help you with your assignment. Okay, cosine rule. You're going to be using cosine rule when you have a situation like this. Okay, I think I drew this diagram before, but I'll do it again. So if you have a situation in which you don't have a right angle triangle, however, one side, two sides, and the angle between these two, and the third side is the missing one, then you're going to be using cosine rule. All right? So if you have a situation like this in which you have one side, another side, and the angle in between, and you want to find the third side, then we're going to be using cosine rule. All right? The other case is when all sides are given. Okay, all sides are given, and you really want to find one of the interior angles. Let's say that you want to find theta in that one. Now, we're going to call this psi angle psi. Okay, psi angle psi. And the other one is psi, 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 because all sides are given, and then you're going to have to find the angle. Okay, so we go psi angle psi, and we go psi, psi, psi. Right? Got that? And this is good because, the problem that some students have is that they have a problem in front of them and they have no idea what rule to use. Okay, so you're going to be doing things by elimination. So you're going to say, okay, this is a right angle triangle or no? If the picture in front of you is a right angle triangle, then you can say, well, I can use SOHCAHTOA, so it's fine. But if you don't have a right angle triangle, then you're going to have to use one of these two rules. You're going to be using this when you have psi angle psi or psi psi psi, And then you're going to be using the other one for any other case. Okay, so we're going to say any other case in a not right-angled triangle. Okay, so I just really want to make this clear. If you have a right-angled triangle, you don't need this. Okay, so you're going to do the SOHCAHTOA and go on to table, that's it. But if you don't have a right-angled triangle, then you're going to be using this. Now, the rules. And then we're going to be doing some question, and then you're going to see that it's actually very easy. Okay, the cosine rule. Okay, cosine rule. More than anything, I want you to remember the structure of the formula more than remembering the formula itself. Okay, because sometimes the formula is given in terms of A, B, C, and then you're going to see some question given in terms of P, Q, R, or Z, U, V. So if you think of A, B, C only all the time, then you're going to get confused with some other questions. All right? Okay. So this is the formula. Let's say that you have this triangle in here. Let's say that this is I, this is B, this is theta, and this is unknown. Okay. So we have the case for triangle psi. Like I say, I'm going to write out the formula. Later, if we have time, we're going to actually prove that the formula is correct. Okay, the formula is like this. If you want to find x, it's a hybrid. So you do x squared is equal to a squared plus b squared. Up to here, it looks like Pythagoras. Can you see that?
Yeah.
X squared equals a squared plus b squared. But then we have another b. So it's minus 2ab, and then multiply by cos theta. Okay, so this is the cosine rule. Now these two is part of the formula. Okay, so you're going to have always 2 in front of the AB. Normally what I do in exercises, I make a big 2 just to emphasize, that fact. So, one day, one of my students asked me, "Hey, sir, how do you put the big 2 in the calculator?" All right? I know why that happened. Okay, sir, how do you put the big 2 in the calculator?
What year was it? Year 10?
Year 10. Okay, so I'm going to say example. Okay, let's say that you have this situation. I. Okay, so we got this triangle. One side is equal to 9, the other one is equal to 12, and the angle between these two sides is equal to 65 degrees. And I really want to find the answer for x. Okay, so that is going to be the first one. Okay, and then we have this one, so it's 58 degrees. All right.
Is that a page?
Yes. Okay, and the question is find the value of x and find the value of p. You can see that this is a dummy, we call this a dummy variable because it could be, It could be called X, P, Q, anything you want. Okay? So the formula normally is given in terms of actually C. The formula that you're going to see in textbook, say C squared equals to A squared plus B squared, but it doesn't matter. It could be anything, all right? Okay, so I just want to make that clear. All right, okay, and then we're going to do this. So we're going to say solution. And you're going to see that at this point it's just substitution. You don't do any fancy or magic or anything, okay, like that. Okay, so you just do the proper substitution and you get the answer. All right, so we're going to see what the formulas say. Okay, so the formulas say x squared equal, and then you're going to square the sides that make up the angle. So you're going to say 9 squared plus 12 squared minus 2 times 9 times 12 multiplied by cos 65 degrees. Okay, and then you're going to put that in your calculator, and after that you're going to have to square root it. Okay, so if you put this, that will give you the answer for the square, but then you need to square root it. Okay?
2 times 9 times 12 in bracket?
No, you don't need to put a bracket. Just put 2 times 9 times 12. Okay, now do you know how to put the big 2 in the calculator?
I don't know.
All right. Okay. All right, put that and then square root it. Sure. Yes, there's one there. Try to go that way so you don't interfere with the camera. All right, can you please tell me the answer for this correct to 2 decimal places?
133.71.
So 11.56. All right. Okay, so you can see that using the formula is very, very easy. And also the structure of the formula is very, very simple. It's not way that you're going to say, oh, you don't remember. No, it's easy to remember. Okay, so you can see it's very, in math, we say that it's very symmetrical. Okay, so you say x squared equals a squared plus b squared, and then take away 2 times those number multiplied by cos whatever the angle is. And the name of the rule is coming from here, because at the end we multiply by cos. Can you see that? So that's why we call this cosine rule. All right. 2. Okay, obviously this time we're not going to say x squared, we're going to say p squared, right? You got p is the unknown, and say p squared is equal. Okay, Mia, tell me what to do.
Oh, no. Hold on. Yeah, so we're going to go 15 squared times 16, plus 16 squared. Yeah, minus 2.
Big 2.
Big 2 times 15 times 16 times cos 58.
Very good. Okay. All right, so 15 squared plus 16 squared minus 2 times 15 times 16 times cos 58. So you put that in your calculator. Make sure that your calculator is set in the right mode. Okay, so it's always DEG. Any other thing, you won't get the right answer. Okay, Jasmine, what is the answer for this, please? 15.05. All right. All right. So using the cosine rule is very easy. So you can see that, right? But the good thing, the good thing about this is that you are not limited to right angle triangle only. Okay, so now you can do any triangle you want. Okay, so you have no limitation. All right. Question 3. Okay, so I'm going to put question 3 in here. All right, let's say that this time you have the 3 sides given. Okay, we're going to go through this, quickly because it's not too hard to understand. Okay, so let's say that this is 10, 12, and let's say 13. And I really want to find the answer for this angle in there. I want to find the answer for theta. Later, I'm going to write down, the formula as you're going to see in textbook. Okay, but for now, I want you to know how to use it. Okay, so if you want to find, have a look. So we are in this case. Okay, so we have side, side, side. Can you see that? So we've done this one. Now we're going to do this one in which we need to find the angle. To find the angle, we're going to be using the same formula, exactly the same formula, but we are going to rearrange it. Okay, so we're going to make cos theta the subject, okay, because we want to find the answer for theta. Now, when you make cos the subject, okay, when you make cos the subject, then the formula is going to look like this, so pay attention. So we're going to say solution for this one. Formula looks like this. Formula, so I'm using the same sort of picture. So we're going to have this. Cos theta is going to be equal to a square plus b square, and then minus the third side. So because we have x in here, we're going to say x squared, and then divided by 2 times a times b, or 2ab. Okay, so if you rearrange this formula, that is what you have. Okay, so we're not going to go through that because I believe that you know how to make the subject from some expression. All right, so like I say, x can be anything. Okay, it could be M, P, Q, R. I'm going to change this time just to make it a little bit more general. I'm going to put C, all right, just to have the ABC.
Oh, so it's...
Yes, it's the same formula. I'm using a more general notation.
Can we take it if we like it?
No, it's more convenient to just go like that. Okay, so now we're going to find the answer for this question, all right? Okay, so we're going to say cos theta is going to be equal to, and if you follow the formula, then it's going to be 10 square plus 12 square, take away the other side, which is 13 square, and then you're going to divide that by 2 times 10 times 12. Okay, at this point you've got to be careful. Okay, so what you are going to do, just to make the calculation simpler, I want you to find the answer for the top line and the top line only. Okay, I want you to find 10 square plus 12 square minus 13 square. Can you please find that for me? 75. And then I want to find the answer for 2 times 10 times 12. 240. All right? And then, do you remember that if you want to find theta, you have to use the second function? Okay, so we're going to say theta then is going to be equal to inverse cos of 75 over 240. And I want you to give me the answer correct to the nearest degree. Yeah, the nearest 72 degrees. Yep. All right.
Someone check that because I don't hear it myself.
Yes. 72 degrees. Okay, so that means that cosine rule is good because it helps us to find a missing side or missing angle. And the formula is simple. And you can see that it's basically substitution. Can you see that? All right. Okay, so now I'm going to put some questions here and you're going to find the answer for them. All right, okay, so Indigo, if you can stop